Let's do one more example of solving a trinomial by factoring. So I've got 5x squared minus 17x plus 6 equals 0. First I look for a GCF. There is none. It's not a difference of squares. It's got 3 terms. So I'm going to be comparing this to ax squared plus bx plus c. Remember, my first step is to find two values that multiply to a times c but add up to b. So in this question, my a times c is 5 times 6, which is 30, and my b is negative 17. So I have to think of some numbers that multiply to positive 30 but add up to negative 17. If they multiply to a positive but add up to a negative, that means they're both going to be negative. And if you think for a few seconds and you can't think of those two numbers, start making a list. I could do 1 and 30, but that adds up to negative 31, not negative 17, so those are not my numbers. I could do 2 times 15. Negative 2 times negative 15 is positive 30, and these are the ones I want. Negative 2 plus negative 15 do add up to negative 17. So I'm going to be replacing my middle term with the two values that I just found. So I'm not changing the 5x squared. I'm not changing the plus 6 equals 0. But I am going to change the negative 17x into a negative 2x and a negative 15x. So my two numbers were negative 2 and negative 15. Next, I group the first two terms together and group the second two terms together and factor out GCFs. 5x squared plus negative 2x, that has a GCF of x. Factor that out. Copy the plus sign. Then I've got negative 15x and positive 6. That has a GCF of negative 3. Factor that out. Copy the equals 0. Now I have my common binomial. And when I factor that out, I'm left with an x and a plus negative 3 or a minus 3. So now I'm down to my zero product property. I have two values multiplied together that equal 0, which means one of them must be 0. So either the 5x minus 2 equals 0 or the x minus 3 equals 0. And I'll solve both of those with inverse operations. So for 5x minus 2 equals 0, first I would add 2 to both sides. And then I would divide both sides by 5. And I get x equals 2/5. That's the same thing as 0.4 if you wanted to change it to a decimal, but I'm going to leave it this way. And for my other equation, x minus 3 equals 0, I'd add 3 to both sides, and I'd get x equals 3. So my two solutions are x equals 2/5 or x equals 3. Remember, you can go back to the original problem and you can plug those in to check your solutions. So if I wanted to do a quick check here, I would copy my original problem, except for when I get to the x's, rather than putting in an x, I'm going to put in one of my two answers. First, let's put in the 2/5. So if I do 2/5 squared, I'd get 4/25. And if I did 2/5 times negative 17, I'd get negative 6.8. And then if I did 4/25 times 5, I'd get 0.8. And I do get 0 equals 0, so I know that that value works. And then the next thing I'd check is the 3. So instead of plugging in a 2/5, now I'm going to plug in a 3. And if I plug in the 3, let's see here, 3 squared would be 9. Negative 17 times 3 would be negative 51. 5 times 9 would be 45. And then 45 minus 51 plus 6, that is 0. So both of our solutions did work.